Good morning, fifth graders. I hope you all enjoyed your weekends. We're starting a brand new chapter now in your book. It's called Topic 12, and it's about collecting data. Specifically, we're talking about one kind of graph that we use to show data we've collected, which is called a line plot. At this point, you should have watched the book video and looked at my other slides, so you know what a line plot looks like. It looks like a number line with dots or X's put on top to show you the data that was collected when researchers asked a certain question. So we're going to look at the two line plots that are on page 701, which hopefully you've also tried a little bit on your own, and go over how to read a line plot and how to answer certain types of common questions you might be asked about one. So if I look at the line plot, first of all, there is always a title at the top. The title tells me what this line plot represents. So for example, this top one here says times in 40-yard dash. That means obviously a bunch of people ran this race called the 40-yard dash. They were timed and they were asked what their time was. Now I see the times below. It says time in seconds. So here's my number line, and I can see that these times are in seconds. So the range of my data goes from 6.8, that is the fastest anybody ran the race, to 7.3, which is the longest time it took anybody to run the race. Each one of these dots represents one person's time. So there are really two different things I could be asked about here. I could be asked about the number of people, like how many people ran, how many people gave a certain time, or I could be asked about the times, like what is the shortest time, what is the longest time, something like that. So let's look at those two different types of questions. Number 4 asks you, how many race times are recorded? So this is asking about how many race times are recorded. That's like saying how many people ran the race, how many people gave their time to be put on this graph. So we're not going to answer this. This is not about the number of seconds it took anybody. We're not going to answer this by looking at the numbers on the bottom of the number line. We're going to answer this by looking at the dots and counting up the dots, because each dot stands for one time that was recorded. So if I want to know how many race times were recorded altogether, I need to count up all the dots. So let's check it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Altogether, 16 times are on the graph. The next question is different. The next question asks me, which time occurred most often? Okay. So now I'm not asking how many times were this, how many times were that, how many people did this, how many people did that. I'm asking which time was most often, was most common, did the most people get? So I need to look just like a bar graph at the tallest one. Which one has the most dots? Oh, it's definitely this one. This is the tallest column of dots. It's got 5 and nobody else has more than 3. So this is the answer. This is the time that occurred most often. 7.1, and my unit is seconds. So 16 people ran the race. Most of them ran it in 7.1 seconds. Okay, now that we're a little more familiar with line plots, let's take a look at another one. The title here tells me that this one is about orders for cheese. Okay. That means each one of these X's is one order. Just like up here, it goes with the title. Each dot is one time that was given. Here, each X is one order that was made for cheese. Now, when I look below, I can see that these numbers on my number line represent the amount in pounds. So people are ordering cheese, they're ordering in pounds. Each X is one person's order, and these numbers tell me how many pounds it was. So now if I look at the questions, I should be asking myself, am I being asked about the orders? Then I'm going to count up X's. Or am I being asked about how much in pounds the orders were for? Then I might have to look at these numbers. So number 6 asks me, how many orders for cheese does the line plot show? Well, I know the orders are represented by the X's. So just like I did for number 4, for number 6, I need to count up all the X's to find out how many orders there are on the line plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. There are 12 orders altogether on this line plot. Okay. Question number 7 asks me, which amount of cheese was ordered most often? So very similar to this one, most often. Which amount, which one of these numbers was ordered most often? Just like when this one asked me which time, I was looking at these numbers. When this one asked me which amount, I'm looking at these numbers. Which one was ordered most often? I'm looking for the tallest one. Oh, it's clearly this one. It's got more X's than any other number. So my answer should be 1/2. And I see my unit is pounds. Okay. So most often people ordered 1/2 pound. Okay. Now I have an example here of a slightly more complicated question that you might be asked. How many more? Oh, I know, and you should too, that when I'm talking about a question that has how many more than, I'm being asked to compare two things and find the difference, which means I'm going to need to subtract. Okay. How many more orders? Okay, so orders, I'm talking about the X's. I'm going to be counting up X's to figure out orders. How many more orders for cheese were for 3/4 pound or less than for 1 pound or more? So this is why this is a little more complicated. They're not asking me how many more this than this, where I can just pick two numbers and subtract. They're asking me how many more whole sections of the graph. So I really need to break down what they're talking about. In front of the than and before the than, and then after the than. Those are the two things that are being compared. So everything in front of the than is 3/4 pound or less. So where would that be on my chart? 3/4 is here, or less means to the smaller side. It doesn't say less than 3/4 because then I wouldn't be able to include 3/4. It says 3/4 or less. So that means 3/4 is part of it, and everything that's on this side, okay? That's 3/4 or less. And they want me to compare that to 1 pound or more. Again, it doesn't say more than 1 pound, it says 1 pound or more. So that means 1 pound is part of it. I'm going to use this section for 1 pound or more. So those are the two things I have to count up and then subtract to get the difference. So if I count up my X's over here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Altogether here, I have 9 orders that were for 3/4 pound or less. Over here, I have 1, 2, 3, only 3. 3 orders that were for 1 pound or more. So if I want to know how many more orders for cheese were for 3/4 pounds or less than 1 pound or more, I'm going to have to find the difference between 9 and 3. So I'm going to do 9 minus 3. I know that equals 6. So my answer is 6 more orders. So they have 6 more smaller orders than the larger ones. Okay, so that is how you solve some of the more common questions that you might be asked on a line plot. Just remember that the title gives you a clue about what each X or circle represents. So if they're asking you about something like times or orders that are listed in the title, or if they're asking you how many people did this or how many answers were given, then you want to count up the circles or the X's that they're talking about. If they ask you about the unit on the bottom, like time in seconds or amount in pounds, then you're looking at the numbers on the line plot to see maybe which was the largest or which happened most often or which was the smallest. Then you might also be asked to come up with whole sections of the line plot and compare those. One more thing I just want to leave you with before the video ends is a little vocabulary. I want you to notice this X over here at 1.5 pounds. Notice how in this line plot, all of these are kind of bunched together. There's no big gaps here, but here is a little bit different. Most of my orders are over here. Then I skip a big space, and this is the only order anywhere in this area. Little vocabulary for you in case you notice it in your work. This is called an outlier. An outlier could be way on the big side of the graph or way on the small side of the graph. It just means that it's a value that's pretty far away from all the others. Most of the values are in one area, and then I have one or two that might be pretty far away. So they're really not average, even though somebody might have ordered that much cheese. I can tell from this graph that that doesn't usually happen. It's not common. Most people don't place an order that big. So if you see the word outlier in your work today, that's what it means. Okay, hopefully you learned a lot from this demonstration. You can go on and try the independent pages and then your practice buddy for homework. Enjoy.